Okay, so lesson 2, surface area of prisms and cylinders. So a prism is a three-dimensional object which has two bases that are the same size and a shape that is parallel to one another. Their lateral sides are rectangles. So here we have a number of different prisms. We can name them. This one would be a triangular prism. We can see that its base and its top are both triangles, right? And that the other three sides are rectangles. We have a rectangular prism. In a rectangular prism, the faces on the top and the bottom are both rectangles. In fact, all sides of a rectangular prism are rectangles. Okay. We have another, this is a cube. It's a specific kind of rectangular, not a cob, a cube. Cube. So it's a square prism. It's like a dice. So all six sides are the same. That one's nice because all you have to do is find one side and times it by 6. Here, we would have a pentagonal prism. So the top and bottom are pentagons, okay? So there's a pentagon at the bottom and a pentagon at the top, all right? The two bases, so the top and the bottom, are the same, okay? I like coloring them to kind of map out what I have, but you can do another thing, and we would do this actually if we were in class. We would actually cut these out and find our nets, okay? So we can use nets, and nets are a way to imagine the shape if you cut all the sides and flattened it out, right? So if you took this and you had little flaps here, you could cut this out and glue it together to form yourself that rectangular prism. This would just be like the gluing tabs, right? So nets are a convenient way to kind of look at a rectangular prism as an expanded or exploded form, okay? So if we look at this, we have a front and the back, and they are the same size and shape, right? So they would be the same, right? Okay, we would have their top and our bottom, and they would be the same. And then we would have, so we've got our front, our back, our top, and our bottom, and then we would have our two little sides here. So side 1 and side 2, and again, they would be the same, right? When we expand it out, when we unfold the net, what happens is that we can see that we have similar shapes. So we really just have 3 different rectangles. We have this one, and it's the same as that one. We have this one, 2 and 2, and we have 3 and 3. So what we can do is to find the surface area of a prism, we find 2 times the front, 2 times the sides, and 2 times the top. Because the top and bottom and the front and back are the same, we're going to account for them, right? So we can say front, back, top, bottom, and the sides. Okay, they're all rectangles, so they're all length times widths, right? So if we had measurements, rectangle, so its area is length times width. If we know their areas, or their length and their widths, we can figure that out. Okay, now here we don't have measurements, so we have to, we can't find that area. We can substitute in some numbers and figure it out. So let's do that. So let's imagine that this side here is 4.4 centimeters. This one here is 2. That would make this 4.4. And that would make this 2. And this would also be 2. And then all I need to know is that last one, and let's imagine that that is 5.9, and they're all centimeters, okay? So looking at each one, for the front, back, area, so this is number 1, area is length times width, which is 5.9 times 4.4, which equals 50, and I have 2 of them, right? So let's see. Let's figure out what it is first. 5.9 times 4.4 equals 25.96 centimeters squared, but I have 2 of them, right? So I have 51.92 centimeters squared for both of them, okay? For the second one, the top and bottom, I have area is length times width, which is 2 times 5.9, which is 5.9 times 2 is 11.8 centimeters squared. So I times that by 2, and I get 23.6 centimeters squared. And whether you incorporate that multiplying by 2 right into your formula to begin with, or as I've done, it's up to you. So you could do 2 sides. You could say, oh, I'm going to combine them. It's 2 times length times width. So 2 times, the sides are 2 times 4.4. So we can combine that, and we get 17.6 centimeters squared. So either way is going to get you the right answer. Now, we've been asked to find surface area. Well, surface area is adding those all up. Surface area, we add them all up. So 51.92 plus 23.6 plus 17.6. And we get for our final answer 93.12 centimeters squared. Now, I just added those numbers in. But if you were given them, you can kind of sort it out and figure it out that way, okay? The exploded view is a great way to kind of tell what's going on and map out the shapes. And we can do that with any prism. So the next one we're looking at is a triangular prism. So again, we've taken the triangular prism and we've exploded it out to kind of see all the shapes. So for this one, we can do the same thing. Now what you'll notice here is with the triangular prism, we only have 3 rectangles. And they may not all be the same because it really depends on the measurement of the triangle. Now this triangle is an equilateral triangle. So they are all the same because this side is 3.5. This side is 3.5, and this side is 3.5. So that means if this side's 3.5, so is this one, and so is this one. So we know that measurement. This measurement is 5.9, so we're adding that in. And for our triangle, however, we need to figure out the height. So we can use our Pythagorean theorem to figure out our height. If we use our Pythagorean theorem, if we take this little piece of a triangle, so this is 3.5. This is 1/2 of 3.5, so it would be 3.5 divided by 2, which is 1.75. But I want to find that height there. X is equal to 3.5 squared minus 1.75 squared. X is equal to square root of 9.1875. So X is equal to did I not get the right number? Let me double check that. Okay, that's right. Okay. So 3.5 squared minus 1.75 squared equals, and I get 3.03 for my height. Okay, so that's 3.03 in there, and that's where I figured it out using the Pythagorean theorem. Okay, so now I have all my numbers that I need. Looking at this, if I sort it out, I have a triangle here. Sorry, I'm going to use a pen, not a marker. Triangle here, 1. It's the same as that one there. And because it's an equilateral triangle, all 3 of these rectangles are the same, and I have 3 of them. So I have 2 times my triangle area plus 3 times my rectangle area. I should write it like that. Okay, so let's figure this out. My area of my triangle, so finding 1, area is base times height over 2, which is 3.5 times 3.03 divided by 2. 3.5 times 3.03 divided by 2. So it's equal to 5.3. And I didn't give units. So let's just say that this is meters. Okay? Because I'm making these numbers up. Okay? So 5.3 meters squared, but I have 2 of them, right? So 2a is equal to 2 times 5.3, which is 10.6 meters squared. So that's for my triangles. Okay, 2 triangles. Now I have 3 rectangles. So this is shape number 2. Area is length times width, which is 3.5 times 5.9, which is 3.5 times 5.9 is 20.65. And we said it was meters, so meters squared. But I have 3 of them, right? So 3 areas, so 3 times 20.65 meters squared is equal to 61.95 meters squared. I want to just double check that. Yes. Okay. So this is my 2. These are my 2 values that I've just spent all this time finding. So I need to add those together, and I will get my total. Okay. So my total is 10.6 meters squared plus 61.95 meters squared, which equals 10.6, 72.55 meters squared. So that's my total. Okay, so you do have to do a little work, a little bit of detective work, but it's really about sorting out what your sides are. Feel free to use different colors to label them with numbers. I'm sorry I wasn't a little better organized when I did this, but you can shade them with different colors and that sort of thing. In general, for prisms, the surface area is the sum of the surface area of all sides. Okay, so you'll have two bases plus the number of lateral sides. Not all prisms are going to have identical rectangles for their sides. A lot of times they do. So it really depends on what's going on with those. Okay, so let's do some more examples. Now that we've kind of sorted that out. Cubes are nice because the surface area for a cube, because all the sides are the same, the surface area is going to equal 6 times the surface area of one side. Okay, so in this case, it's a surface area, it will be 6 times s squared. So s is 8 squared. So 6 times 8 squared is 384 centimeters squared. Okay, the cubes are the simplest prism in a lot of ways, because all 6 sides are the same, right? That's weird. Alrighty, now let's do a little example here. You purchased a gift for your uncle. It came in a 12 by 12 by 32 centimeter box. So we see our picture there. Now it's time to wrap the gift. How much wrapping paper will you need to cover the gift box, assuming no overlaps? So this tells me, the 12 by 12 tells me that the ends are squares. And that also tells me that all 4 of the rectangular sides are going to be the same. So I have my bases, which is 2 times those squares, right? And I have my lateral sides, which is 4 times the rectangle. Now on the square, the side is 12. On my rectangle, it's 12 by 32. Okay, so this will equal 2 times 12 squared, which is 288, and it's centimeters squared. And this will be 4 times length times width, which is 12 times, let's write that out, 4 times length times width, which is 4 times 12 times 32, which is equal to 1536 centimeters squared. The total surface area total equals 288 plus 1536, which equals 1824 centimeters squared. Okay, so it's just kind of sorting out what's there. If it helps you to draw a picture, draw the net, you can do that. Next we have a triangular prism. Okay, so we're looking at this one, and we're going to find the surface area to the nearest whole number. Now here I don't have an equilateral triangle because the base is 8 centimeters and the height is 3 centimeters. So I need to use my Pythagorean theorem to find those the sides, the other sides. Okay, so if I look at this triangle, and that means this is 3, and you're saying, why do we care about the height? Why do we care about the height? Oh, because we need to find it for the triangles area. So this would be 4, so we're going to use the Pythagorean theorem to find the missing side. So x is equal to c squared minus a squared. So it's c is, that makes no sense. This is incorrect, right? You know what? I think that's actually for this. Oops. So we're finding that side. Oops. So let's delete this. Good thing I'm doing this, right? So this is 3, that's 4, and we're finding that side. So we need to find the missing side. It's the hypotenuse, so that means it's going to be x is equal to a squared plus b squared, which is 4 squared plus 3 squared, which equals 16 plus 9 square root of 25, so it equals 5. So that means this side and this side are both 5s. Okay? So now we know that what we have when we look at our rectangles is we have 2 triangles, okay, which have a height of 3 and a base of 8. Okay? We have 2 rectangles that are identical that have a side of 5 and a base of 12. And then I have 1 rectangle all by itself which has a width of 8 and a side of 12. So I've got to find 3 different surface areas, or areas. So 2 times a triangle, 2 times base times height over 2, plus 2 times the rectangle, 2 times length times width, plus 2 times this rectangle. And I'm just going to notate my length width differently. I'll put an L1 and W1 just so they're different. So here, our base times height is 8 times 3 over 2. For this first rectangle, it's 12 times 5. And for this one, oops, and I shouldn't have written a 2 there, right? Because we only have one of them. 1 times. We don't multiply by 1. So this will just be 12 times 8. Now, make sure you do each of these separate, right? So this is the triangle, this is this one, and this is this one. Do those separate and then add up last. You don't want to get order of operations to mess you up. So the first one should give you 24. Second one should give you 120. And the third one should give you 96. So our total surface area equals, we add that all together, 240, and it's centimeters squared. Okay, so it's really about breaking it down into the pieces and determining what those pieces are. Okay? Alrighty. Let's do some more examples. Oh, or will we? Yes, we're going to talk about cylinders. A cylinder is, because we're doing prisms and cylinders, and the difference with a cylinder is that it's a 3D object where the base and the top are circles. And when you unwrap a cylinder, what you notice is you get, scrolling back, sorry. When you unwrap a cylinder, what you notice is you get 2 circles that are identical and a rectangle. And the nice thing about a cylinder, I think it's nice, is that we actually get a formula that always works for surface area. So when we see it's a cylinder, we don't have to be counting sides and figuring out the height of the triangle on the end, because we just use the formula that we're going to be given now. And it's based on the fact that you have 2 circles, and that when you unroll that rectangle, the length of that rectangle is equal to the circumference of the circle. And that's why we did that circumference practice earlier. So the formula for surface area of a circle is 2 pi r squared. This is for the 2 circles, plus 2 pi RH, and this is for the rectangle. Okay, Now, if you want to know how the parts work, the 2 pi r is the length of the rectangle, and the h is the width. So the height of the cylinder is our width. So it's just interpreting them that way. So here, I love it when we're given a formula, right? Because all you have to do is say, oh, I got a cylinder. And you take that formula and you substitute things in. And as long as you substitute the right things in, you're groovy. Okay. Watch out when we're talking about diameter versus radius. Okay. Because that might be the trick. So here, first question says, dun, 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 it says the diameter of 10.2 and a height of 15.4. So remember, we learned that radius is equal to the diameter divided by 2. So the radius will be 10.2 over 2, or dun, 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 5.1, and it's centimeters. Okay, so we needed to do that calculation first. Sometimes we math teachers will trick you up that way. Our height is 15.4 centimeters. So you have your two pieces of information that you need. So we just take our formula. Surface area of a cylinder is equal to 2 pi r squared plus 2 pi rh. And we're just going to substitute in what we know. So 2 pi r is 5.1 squared plus 2 pi 5.1 times 15.4. We'll figure out each of those pieces. So 2 times pi times 5.1 squared equals 163.43 plus 2 times pi times 5.1 times 15.4, 493.48. So our total surface area, we add those two together, and we get 656 I can say 0.9 centimeters. We're going to round, right? Centimeters squared. It's area, so the units are squared. Okay? So just be careful. This one gave you diameter, and you need the radius. All right, let's do another example. I like prisms. Or cylinders, sorry, because it does have a formula. Anywhere where a formula is given, I go, woohoo, because I don't have to do a lot of thinking. Lazy. All right, so let's look at the next one. The next one says, a hockey puck is 2.5 centimeters thick and has a diameter of 7.6 centimeters. What is the surface area of the puck to the nearest centimeter squared? So again, we were given the diameter, 7.6 centimeters. So the radius is equal to the diameter divided by 2. So that's 7.6 centimeters divided by 2. So our radius is 3.8 centimeters, right? And our height is 2.5 centimeters. So we have our two measurements. So surface area is equal to 2 pi r squared plus 2 pi rh. We substitute in 2 pi r squared is 3.8 squared plus 2 pi r is 3.8 and h is 2.5. We're going to multiply this first one. We'll get 90 point, let me do it again, 2 times pi times 90.773, okay, 72, blah, 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 blah. There's more, right? And then the second one is 56.6. I gotta figure that out. 2 times pi times 3.8 times 2.5. which gives me, oh, I get, did I put everything in right? 2 times 3.8, 2.5, okay. This is, I made a mistake here. Never trust someone else's work. So I get 59.69. So my surface area, which is not AS, it's SA. I add those two together. And I get 150.419, 150.419, but it says here to the nearest centimeter, so I can just write 150 centimeters squared. Okay, it's great that we have this formula, and the formula will help us do our work. Now it's your turn to practice. Remember, when you're dealing with a prism, so looking at these, you're going to want to split it open. You want to think about all the sides that are involved. Sometimes it's hard to visualize that, so it might be good for you to sketch it out, because that will help you. With cylinders, you get a little bit of a break because it's just substituting into the formula. Remember, if your prism has a triangle on the end, that you need to have the height. You might have to use the Pythagorean theorem to figure out the length of all the sides. Sometimes they're given, but sometimes they're not. Okay, and I can see one right there, this one, where you're going to have to use the Pythagorean theorem to figure out the side. Okay, so you got some practice to do. It's a lot of figuring out what we're dealing with, and a lot of multiplying and